Right. Welcome back to our tutorials. So, last time we were speaking about the induction of electricity. So, the thing that I did not mention here was electricity generation, um, and what are we trying to calculate here, or what are we working on, right? So, with alternating generators, obviously, um, the entire uh, part we were speaking about two things. We were speaking about generators and motors, right? And motors. So these generators are important, and these motors are also important. Hence, we were speaking about AC, and we were speaking about the direct current. Now, in this video, we're going to be dealing with the electric uh, conduction from the power station, right? So, in South Africa, we get our electricity from Kahora Basa. So, we also have mines in South Africa, but that is like the biggest electrical contributor or supplier, right? So the electricity will go from the main power stations, right? So from the when the coal is burnt under the controlled conditions in huge boilers, the heat converts water to steam under high pressure. So now the heat moves to the turbine and spins the blade of the turbines. So in the turbines, the motion of the turbines, you can take it to be the motion of the coil, right? So now the turbines, when they move, the turbine shaft is linked to the rotor of an electromagnetic generator that is spins inside a large copper coil. Now this generates electricity due to the moving turbine, which is commonly known as a coil to us, right? So now the moment it starts to move, right, uh, then then can electricity be generated using the electromagnetic generator that spins inside a large copper coil. So now the electricity flows into transmission lines at a high voltage, right? So transmission lines close to consumers reduce voltage. That's why we have your step up or your step up or step down converters, right? Right. So the step down is used to decrease the high voltage from the from the main lines, so that it can reach our home, right? So these are not just converters. We call these converters transformers, right? So these transformers, they are the ones that reduce or that increase electricity in our home. So now, a cold process condenses the steam back into water so that it can be pumped back into the boiler tubes for reheating. So some of the cooled water um, evaporates as steam from the large cooling tower. So now the gas um, from the burnt coal is filtered, and 99.8% of the ash is removed, then released from the smoke stack. That is basically how we generated how we get our electricity. So now I'm not gonna get into too much detail. I just want us we calculate for 5 minutes. For the coming 5 minutes, I want us we calculate for AC. The voltage of AC is equals to your V cold, right? I mean V max, sorry. It's V max sine. Is it the sine or is it cos? I think it's cos. It cannot be sine. Cos theta, right? Now that is the voltage, right, in AC form. So AC current is I equals to your I max, right, cos, I mean sine theta, right? Now that is basically that. So remember that for AC generators, your graph is gonna take this form here. It's gonna take this form, right? So this is going to be your V and this is going to be a negative V, right? So with that being that, now remember that the coil is turning, so you're going to use theta, the angle to which it is turning. So now AC power, we say AC power is equal to I squared R. Remember that this formula comes from the formula V equals to IR, right? So now that we have IR here, now power is equals to VI. So if we substitute VI there, we can have power as if we calculate V as IR times I. So I times I is I squared R. That is where we get this formula. So now with that, we can say this is equal to I squared. Remember that this is going to be what? Sine squared theta R. Right? Now we will talk about that as this is I max, right? This is I max squared sine theta squared. So now we will continue talking about this as time goes on. Now I want us we move to calculations quickly. Just want to save time. Okay. Yeah, we have calculated that. So now the P average of that is going to be IRMS multiplied by your VRMS, right? That is basically our basic formula, where IRMS is equal to I max, right? I max over the root of 2, and VRMS equals to V max over the root of 2. Now let's try to solve an activity here, or let's go through this ones here. Let's see. Okay, yeah, here's an example that we can do quickly. I'm just gonna do this. Yeah, I'll try to talk about transformers, but already we spoke about them, the step up and the step down. So let's take an example. Number A, they're saying that the power of a hair dryer is 1000. It is what? A hair dryer marked, right, 1500 watts, right? Now is connected to a 230 volts plug point. Determine the maximum peak voltage. So now this is the VRMS. VRMS is the step down of current. So we want to know the maximum current of this, or the maximum voltage of this. So to know the maximum, remember Vrms equals to Vmax over the root of 2. So now Vmax equals to Vrms the root of 2. Now if we can substitute that, we're going to have what? 230 multiplied by the root of 2. What we get there is how much? Is 235 volts. So now let's go to B here. What do they say? Calculate the determine the maximum resistance of the hair dryer. Determine the maximum resistance of the hair dryer. Remember from the equation P equals to VI, right? Now we can try to include resistance to this. If we say V, remember V equals to IR, right? So now I is equals to V over R. So we can substitute it here. So we can say this multiplied by V over R. Then the average power is going to be V squared over R. So now the V squared that we are going to use, it's the Vrms, and this is going to be our average power. Okay? So now having the average power, this is what we're going to do. They're saying calculate the resistance. So now R is going to be V squared over Vrms over P. This is how, if you cross multiply this, you're going to have V squared RMS, which is equals to RP, then divided by P divided by P, sorry. This will cancel this, then R will be Vrms squared plus P. So now we can substitute the 230 squared over the power 1500. So how much do we get there? 230 divided by that. How much do we get there? I think we're gonna get something like 35.1 ohm. So that is the resistance they wanted us to calculate. Now for C, they say to you, do what? They calculate the current given by that. Remember, P average equals to I RMS V RMS. So now we can calculate the current by dividing by VRMS. I RMS is equals to P average over VRMS. So now if we have 1500 here, we're going to divide it by 230. Now let's see how much do we get there. Well, if we divide it by that, we get the 6.52 ampere. Now that is it's basically the simplest way of dealing with questions related to that. There's no other type of questions that will come except these ones. So you're just gonna use the same electricity formulas, just that you're going to put your max and your RMS. You have to know how you work around this. Now how did we know that this is the RMS? We knew that this is the RMS because they said connected to a 230 plug point. So if it was on the main line, it was gonna be our maximum. Remember, each house is powered by 230 volt. So which means that the plug they are talking about is the plug that is on the main box. So you have to bear those in mind. When we calculate using this, we are calculating the actual voltage in our houses or in our appliances. So it's most practical. So yeah, that is basically that. If the voltage is greater than 230 or 240, in most cases, that means, I'm not saying in all cases, in most cases, that means that it is going to be our maximum voltage or current. Now, if the current is within the limits of this 230 voltage, then that means we are in the households. So practically that's just that. Yeah, that's just that. Let's try. We have transformers. Transformers are electrical devices that play important part in modern technology, radios, televisions, and whatnot. Now, transformers are used. All right. Let me start here. A transformer is made up of two circuits, right? Um, two circuits of loop wires which wound around it. So yes. So now with this transformer, you just have to know their use or the main purpose of their main purpose. So the main purpose of a transformer is to convert electricity either to increase the electricity or to decrease the electricity. Now we have the step up and the step down transformers, right? So that is how we can deal with that. So the transmission of AC power, the power station generate alternate current of about 2000 22,000 volts, right? 22k volts, right? So now most end users are far away from the power station, so the power has to be transmitted over long distance. Now if the power was DC, it would require a large amount of cabling and result in very large loss in power, to form what? P equals to IR. So electricity in at the power station is in AC, DC is in our homes, right? So now, so however, with the use of transformers, AC power can be transmitted lightly with a resulting decrease in current. So this minimizes power losses. The reason why we have this RMSs here is to reduce. Where is it? This RMSs is to reduce current efficiently, right, without losing the power, right? This RMS means root mean value square. The V is silent, so this root mean is the mean value is one word, right? Root mean value square. So that's what it basically means, right? So yeah, to those guys, next time.